There is a moment, just before the sun clears the horizon, when the world holds its breath. The light comes in sideways, thin and gold and precise, and it falls across a surface that has been waiting for it, not for hours, not for days, but for thousands of years. The stone receives the light the way a letter receives a reader. Unhurried, patient, certain that this moment was always going to come. Somewhere on this planet right now, in a place that most maps still label as empty, a massive stone structure stands in a landscape that has barely changed since it was built. From the air, it looks almost too symmetrical to be real. Its angles are too clean. Its proportions hold something that the eye registers before the mind can name it. A kind of rightness, a logic that feels older than language. Standing at its base, the stone is not merely large. It is impossible, not in the casual sense of the word, but in the precise, technical sense. The methods required to place these stones, to cut them this precisely, to align them with this degree of accuracy, those methods strain the limits of what modern engineering could replicate today. And yet here the stone stands, and here it has stood, through every earthquake and empire and forgetting, waiting with the patience of something that knows it will eventually be understood. What pulls at the mind is not just the size, it is the intention. Every angle of this structure was chosen. Every proportion was deliberate. And if you look long enough, if you let go of the comfortable story that ancient people were simply not as intelligent as we are, a different story begins to assemble itself from the shadows. This stone was not placed by accident. It was placed by someone who understood something precise, something mathematical, something that reaches far beyond what the history books give them credit for. And when you discover that the exact same understanding appears in a structure built on the other side of the world, by a people who could not possibly have met the builders of this one, that is when the comfortable story finally falls apart. Something was known, something was encoded, and it is still here, waiting. In the hills of Lebanon, at a site called Baalbek, there is a stone that has no explanation. Not a metaphorical stone, an actual stone. Still lying in the quarry, where it was partially cut from bedrock over 1,000 years ago, or possibly much longer than that. It measures roughly 20 meters in length. It weighs somewhere between 800 and 1,000 tons. And here is the thing that engineers come to stand before and go quiet. It was not the only stone like this at the site. Several others were moved, lifted, placed in walls with a precision that their mass makes almost geometrically impossible. No crane in current operation can lift 1,000 tons. And yet someone did. Someone lifted stones of this weight and set them into a wall with gaps between them, so fine that even today, after centuries of seismic activity and erosion, you cannot insert the flat blade of a knife between them. Go further south and west. Find yourself in the highlands of Peru, at a site called Sacsayhuaman, and stand before walls made of stones that are not rectangular. They are not even close to rectangular. They are polygonal, 10, 15, 20-sided shapes, each one unique, each one cut to fit against its neighbors with such precision that the joint between them is essentially invisible. No mortar, no cement, just stone touching stone across surfaces that are not flat, are not simple, and should by any reasonable calculation require cutting tools of extraordinary sophistication to produce. The largest blocks here weigh over 100 tons. Cross the Pacific. Arrive on a remote volcanic island in the southeastern Pacific, a place so isolated that the nearest inhabited land is over 2,000 kilometers away. Easter Island. A civilization with no metal tools, no written engineering tradition, and no obvious access to the quantity of labor that these projects would require, produced nearly 900 enormous stone figures, the moai, and moved them across uneven terrain to precise coastal positions. The largest erected moai stands nearly 10 meters tall and weighs around 80 tons. It was transported to its platform location using methods that archaeologists still genuinely debate. None of these examples is a myth. None is an exaggeration. They are physical objects that can be measured, dated, and visited. And they are merely 3 examples from a list that runs to dozens of sites across every continent on Earth. The pattern is unmistakable once you let yourself see it. Ancient builders achieved things that should not have been achievable, with consistency and precision that rules out accident. What scholars are reluctant to ask, because the question leads somewhere deeply uncomfortable, is whether these impossibilities share a common cause, whether they all come from the same place. Not geographically, mathematically. Take the Great Pyramid of Giza. You already have an image of it in your mind. Set that image aside, because what is actually there is stranger than the image. The pyramid was built approximately 4,500 years ago. Its base is nearly perfectly square, not approximately square, not roughly square, but square to within a margin of error, smaller than a centimetre, across a base length of 230 metres. Each of its 4 sides faces a cardinal direction, with a precision that exceeds the alignment of the Greenwich Observatory when it was first constructed. The structure is positioned almost exactly at the geographic centre of the Earth's landmass, the point on the planet's surface that divides the world's land area into equal halves. That positioning alone required the builders to have a comprehensive knowledge of the planet's geography. But the geometry inside the proportions is what changes everything. If you take the perimeter of the pyramid's base, the total distance around all 4 sides, and divide it by twice the pyramid's height, you get a number. That number is 3.14159. Pi, the mathematical constant that describes the relationship between a circle's circumference and its diameter. Pi, which the ancient Greeks who are credited with first calculating it with precision, worked out roughly 2,000 years after this pyramid was built. The pyramid encodes pi to 4 decimal places. The Egyptians' own written records, preserved in what is called the Rind Papyrus, show them using a value of pi equivalent to 3.16, which is less accurate than the value encoded in the physical structure of their most famous monument. The pyramid is more mathematically precise than the mathematical documents left by the culture that built it. Sit with that for a moment. Then consider that the same ratio pi, encoded in the relationship of a structure's height to its base perimeter, appears in the Pyramid of the Sun at Teotihuacan in Mexico, a structure built by a different civilization on the opposite side of an ocean, approximately 1,000 years after the Great Pyramid, with no documented knowledge of or contact with Egyptian engineering traditions. The same number, the same encoding, the same precision. And then consider that the circular geometry of Stonehenge, when analysed, yields the same ratio in the relationship between its circular layouts, and that Angkor Wat in Cambodia encodes it in the proportions of its towers, and that the ancient temples of India express it in the geometry of their floor plans. The same number, everywhere, hidden in stone, waiting to be read. What you have just encountered is not the end of the discovery. It is the doorway. Over the course of this journey, we are going to move through ancient Egypt and Mesopotamia, through the highlands of Peru and the jungles of Cambodia, across the stone circles of Britain and the carved monuments of sub-Saharan Africa. And what we are going to find consistently, verifiably, and without exception, is a mathematical language encoded in stone that no single civilization should have possessed. Some of what follows is accepted by mainstream archaeology. Some of it is the work of independent researchers working at the edges of what institutions will sanction. Some of it remains genuinely unresolved questions that the evidence demands be asked, but that the academic world has been slow to answer. Where those boundaries exist, they will be clearly named. The goal here is not to make claims that the evidence cannot support. It is to follow the evidence honestly, all the way to the end, and to resist the comfortable habit of stopping just before the question becomes truly difficult. Here is the most important thing to hold as you follow this story. Geometry is not a human invention. No one designed it. No one created it. It was already there, embedded in the structure of the physical universe, before the first human being arrived to observe it. Pi was true before anyone measured a circle. The golden ratio existed in the spiral of the first Nautilus shell, long before any civilization built a temple. These ratios are not cultural, they are cosmic. And if that is true, if geometry is something discovered rather than invented, then every ancient culture that encoded it in stone was not creating something original. They were remembering something that existed before their civilization, before any civilization we have yet named, something older than all of them, something that may have left its signature not just in stone, but in the very fabric of reality itself. That is where we are going. Mention the phrase sacred geometry in most conversations and watch what happens. Eyes glaze slightly. The mind reaches for associations, crystals and mandalas, the decorative swirls on a yoga studio wall, the kind of thing printed on a poster above someone's meditation cushion. It is a phrase that has been borrowed by a certain kind of modern spirituality and used in ways that obscure rather than reveal what it actually points toward. Strip away those associations. Set them aside completely. What remains is something far older, far more precise, and far more intellectually substantial than the aesthetic borrowings of the last few decades. Sacred geometry, in its original and most precise sense, is an observation. It is the observation made independently by cultures across the ancient world that specific mathematical ratios and spatial relationships appear with extraordinary frequency in both the natural world and in the structures. Those cultures considered most important. It is not a belief system, it is a pattern. Patterns do not require belief, they require observation. Consider a nautilus shell. As the creature inside grows, it builds outward in a spiral. Each chamber it constructs is larger than the previous one, by a ratio that remains constant throughout its lifetime. That ratio is approximately 1.618. The shell does not know mathematics. It simply grows according to the logic built into its biology. But the ratio it produces, that specific number, is the same ratio that appears in the arrangement of seeds in a sunflower, in the branching angles of a tree, in the proportions of the human skeleton, in the orbital resonances of the planets in this solar system. A beehive builds perfect hexagons. Not approximately hexagonal, exactly hexagonal, to a precision that requires the minimum material to enclose the maximum space. This is the optimal solution to a specific engineering problem. The bees did not solve the problem with calculation. They solved it with biology that is itself an expression of mathematical law. A fern unfurls in a spiral that exactly mirrors the spiral of a galaxy. The pattern of veins in a leaf follows the same branching logic as the pattern of rivers in a watershed as seen from space. The same mathematical relationships keep reappearing, at every scale, in every system, in every corner of the observable universe. The ancients noticed this. They noticed it with extraordinary care, and they drew a conclusion that is startling in its simplicity and its depth. The universe is written in mathematics, not metaphorically, literally, and the most sacred thing a civilization could do was to build its most important structures in the language of that mathematics, to make visible, in permanent stone, the same geometric logic that governed everything from a shell to a star. That is sacred geometry, not decoration, evidence. The year is approximately 9,500 BC. Agriculture has not been invented yet, the wheel does not exist. Writing is 10,000 years in the future. Civilizations, as far as conventional history is concerned, are also 10,000 years in the future. In the hills of what is now southern Turkey, a group of people, hunter-gatherers, by every archaeological measure available to us, are engaged in a construction project of extraordinary complexity. They are quarrying limestone blocks weighing between 10 and 20 tons from a hillside. They are shaping those blocks into T-shaped pillars, with carved reliefs of animals and abstract symbols on their surfaces. They are arranging those pillars in precise circular enclosures, each pillar positioned at mathematically consistent intervals from its neighbors. They are building multiple enclosures, and when those enclosures are plotted together on an architectural plan, the spatial relationships between them reveal a larger geometric order that is clearly deliberate. When they are finished, perhaps decades later, they fill the entire site with earth and rubble, burying it deliberately, and they move on. This place is called Göbekli Tepe. It was excavated beginning in the 1990s by German archaeologist Klaus Schmidt. Its implications have been reverberating through the academic world ever since, because it breaks the conventional timeline of human civilization at its most basic assumption. Hunter-gatherers people without agriculture, without settled society, without the surplus food production that is supposed to be required to organize large-scale construction projects, built a geometrically sophisticated temple complex that predates Stonehenge by 7,000 years, and the futile Egyptian pyramids by 6,000 years. Nobody lived at Göbekli Tepe. There are no hearths, no food waste middens, no evidence of permanent habitation. People came to this place specifically to build, and then they left. The building itself was the purpose. The geometry was the message. Forward several millennia to ancient Mesopotamia. The Sumerians, often credited with inventing civilization itself, left written texts describing the foundational principles upon which their society was built. They called these principles the Me, a divine set of laws and measurements that their texts describe as having been given to humanity by the gods. Among the Me were principles of proportion and measurement that, when examined, correspond directly to the geometric ratios found in sacred architecture across the ancient world. The Sumerians did not believe they had invented these principles. They believed they had received them. The same story appears in ancient Egypt, where temple dimensions were governed by what priests called the divine canon of proportion. Measurements described as existing before the physical world, as the template upon which creation itself was modeled. And in ancient India, where the Vastu Shastra, the sacred architectural text, describes its geometric specifications as eternal laws, not human innovations. Every tradition says the same thing. The geometry preceded them. They were not its inventors. They were its students. There is a number that keeps showing up. It appears in places that should have nothing to do with each other, in the spiral of a galaxy and the curve of a wave, in the arrangement of leaves on a stem, and the proportions of a face that the human eye instinctively finds beautiful. It is approximately 1.618, and mathematicians call it phi, and the ancient world called it the divine proportion. And once you have truly encountered it, you will begin to see it everywhere you look. Here is what phi is, in its simplest form. Take a line, divide it into two segments, such that the ratio of the entire line to the longer segment equals the ratio of the longer segment to the shorter one. The ratio at which this self-referential balance occurs is phi 1.618. It is a proportion that contains itself, a ratio that mirrors the relationship between the whole and its part at every level of subdivision. Mathematically, it is the only ratio in existence where the proportion of the whole to the large piece equals the proportion of the large piece to the small piece. It is, in a very precise sense, the mathematical definition of harmony. In nature, phi governs the spiral of the nautilus shell, the arrangement of seeds in a sunflower head which pack themselves into opposing spirals, whose numbers are always consecutive. Fibonacci numbers, the angle at which leaves emerge from a stem to maximize sunlight exposure, the proportions of the human hand and face, and the orbital resonances of several planets in the solar system. It appears in the double helix of DNA. It appears in the frequency ratios that the human ear perceives as musically harmonious. And it appears in stone. Stand before the Parthenon on the Acropolis of Athens. The rectangle formed by the building's facade, the relationship of its width to its height, is a golden rectangle. The ratio between its longer and shorter sides is phi. Now overlay a golden rectangle on the Pyramid of the Sun at Teotihuacan in Mexico, built by a civilization on the opposite side of the Atlantic from the Greeks, centuries later. The proportions match. Now apply the same analysis to the Temple of Karnak in Egypt, and to the great Moai platforms of Easter Island, and to the ancient temples of Angkor Wat. Phi is there, in every one of them, not approximately precisely. Leonardo da Vinci spent years studying the proportions of the human body and encoding his findings in the drawing known as the Vitruvian Man, the famous image of a figure inscribed within both a circle and a square. What da Vinci was doing was not original observation. He was drawing on ancient traditions that had already mapped the golden ratio onto the human form and encoded it in architectural proportions. He was, in a very literal sense, decoding what the ancients had built. Leonardo did not discover the golden ratio. He rediscovered it. And somewhere behind him, in the deep past, someone else discovered it first and built it in stone, so it could not be forgotten. The question is not whether phi is encoded in ancient architecture. It is. The question is why the same number, with the same precision, appears in structures built by cultures that had no known contact with each other across every corner of the inhabited world. Every language needs an alphabet. The language, spoken by ancient sacred architecture, was no different. It had a specific set of fundamental elements, each one carrying meaning, each one appearing in structure after structure across the ancient world. To follow the rest of this journey, it helps to know these elements before encountering them in the stone. Pi, the ratio of a circle's circumference to its diameter, is the language of wholeness and completion. The circle was the universal ancient symbol of the divine, because it has no beginning and no end, and pi is the mathematical constant that describes its fundamental relationship. Any structure that encodes pi in its proportions is making a statement about the infinite. The square root of 2, the ratio that describes the relationship between the side and the diagonal of a perfect square, appears in the king's chamber of the Great Pyramid, in the proportional layout of Stonehenge's geometry, and in the floor plans of Greek temples. It is the ratio that connects the two-dimensional world of the square to the diagonal dimension that cuts through it mathematically. It is the bridge between two planes of reality. The vesica piscis is a shape formed by two circles of equal radius, overlapping such that the edge of each passes through the center of the other. The almond-shaped overlap region between them was considered by ancient traditions to be the geometric representation of creation itself, the space between two holes that produces a third thing. It appears in the foundational geometry of Celtic stone circles, in the floor plans of ancient Egyptian temples, and in the proportional systems of Gothic cathedrals. The Fibonacci sequence, the numerical series in which each number is the sum of the two before it, producing 1, 1, 2, 3, 5, 8, 13, 21, 34, and continuing infinitely governs the spiral growth of natural forms. As the sequence progresses, the ratio between consecutive terms converges toward phi. These are not two separate mathematical phenomena. They are the same phenomenon expressed in two different ways, one as a ratio, one as a growth sequence. These are the keys, the ratios, the spirals, the self-referential numbers that the ancient world encoded in its most permanent structures. Learn their faces, and you will begin to read a language that has been hiding in plain sight for thousands of years. The ancient Egyptians built their temples according to precise geometric specifications. This is not unusual for architecture, but the Egyptian understanding of why those specifications mattered was not a matter of engineering. It was a matter of cosmic law. The Egyptians called the underlying order of reality Ma'at, a word that translates as truth, justice, and cosmic balance simultaneously, because in their understanding, these were not separate things. Ma'at was the principle that held the universe together, the law that kept the sun rising, the stars in their courses, the Nile in its annual pattern of flood and retreat. And the temples they built were not representations of Ma'at, they were physical expressions of it. A temple built with incorrect proportions was not merely aesthetically flawed. It was cosmically broken, unable to serve as the channel between the divine order and the human world that a temple was supposed to be. The architects were not engineers. They were priests, performing the most fundamental act of their religion, enacting the mathematics of creation in physical form. In ancient Greece, Plato described the 5 perfect geometric forms that he believed were the fundamental building blocks of the physical universe: the tetrahedron, cube, octahedron, dodecahedron, and icosahedron, each corresponding to one of the classical elements. These Platonic solids, as they are still called, were not philosophical poetry. They were Plato's attempt to describe the mathematical structure of reality itself. His famous statement that God always geometrizes was not a metaphor. It was his literal description of how the universe operates, and Plato's framework was not original. He was drawing on the Pythagorean tradition, which itself claimed to be recovering Egyptian wisdom. In ancient India, the Vastu Shastra, the sacred text governing architectural practice, describes the proportions and orientations of a correctly built structure as the framework through which divine energy moves through physical space. The geometric specifications are not aesthetic preferences. They are functional requirements, like the dimensions of a pipe designed to carry a specific fluid. Build them incorrectly, and the energy does not flow. Build them correctly, and the building becomes, in the Sanskrit term, a yantra, a physical instrument for interacting with the divine order of the universe. 3 traditions, 3 continents, 3 detailed, sophisticated philosophical systems, all converging on the same conclusion. Geometry is not something human beings invented for practical purposes. It is the language in which reality itself is written. And building in that language is the most important thing a civilization can do. The most sophisticated building project in recorded history has no architect's name attached to it. This is not a small detail to overlook. Every civilization leaves administrative records when it undertakes a major construction project. Lists of workers, accounts of materials, the names of supervisors and master builders. The Egyptians were obsessive record keepers. They documented grain deliveries, cattle counts, the daily movements of their court. They left inscriptions on almost every surface they built. And yet for the Great Pyramid, a structure that required the sustained labor of tens of thousands of workers over 2 decades, that consumed resources on a scale that would challenge a modern nation-state, that achieved engineering precision, that humbles contemporary builders, the architect's name does not appear. The construction method is not described. The source of the mathematical knowledge, encoded in its proportions, is not explained. Travel to Bolivia. Find your way to the Altiplano near Lake Titicaca, to a site called Puma Punku. What you will find there are stone blocks, massive stone blocks that have been cut and shaped with a precision that stops engineers in their tracks. The cuts are clean to the millimeter. The corners are exact to the degree. The stones interlock like machine-manufactured components, and Puma Punku has yielded no pottery, no organic material for carbon dating, no construction, waste nothing that would allow conventional archaeological methods to place it firmly in time or identify the people who built it. At Göbekli Tepe, the builders left no houses, no burials, no personal objects. They built their temple and erased themselves from the record with what looks, from this distance, like deliberateness. At Stonehenge, the builders of the earliest phase, the phase that includes the most precisely geometric earthworks and the original placement of the Aubrey holes, are referred to in archaeological literature simply as the Stonehenge people, not a tribe name, not a culture name, just a description of what they did, because nothing else about them survives. This absence is itself a pattern. The most geometrically sophisticated structures in the ancient world are precisely the ones whose builders are least known. It is tempting to attribute this to the simple erosion of time. But there is another explanation, one that the geometry itself suggests. What if the builders intentionally left no biographical record? What if the only record they intended to leave was encoded in the stones themselves, in the proportions and alignments and mathematical relationships that do not erode, that do not depend on language, that will be readable by any civilization sophisticated enough to measure them? What if the geometry is the archive? Every great ancient civilization left traces of a specific institution, a group of people who possessed specialized architectural knowledge that was not available to the general population, who transmitted that knowledge through secret or restricted channels, and who were responsible for the most geometrically sophisticated construction projects of their era. In ancient Egypt, this institution was called the House of Life, a kind of sacred academy attached to the major temple complexes, where the deepest principles of architecture, mathematics, astronomy, and medicine were preserved and taught. We know the House of Life existed. There are inscriptions referencing it at Abydos and at Edfu. We know that the knowledge preserved there was considered secret, restricted to initiated priests and architects, not available to ordinary people. What we do not know is the content. The House of Life did not leave a curriculum. In ancient India, the master builders were called the Sthapati, a hereditary caste of architects who preserved the principles of Vastu Shastra across generations, passing the knowledge from father to son through a tradition that stretches back further than any surviving written record. The Sthapati were not merely builders. They were custodians of a complete cosmological system encoded in architectural form. Some families maintain this unbroken tradition to the present day. In ancient Greece, Pythagoras established a school that modern accounts tend to describe as a mathematical society. It was not. It was a mystery tradition. Members took oaths of secrecy. The knowledge they studied, which included not just mathematics, but music, astronomy, and the philosophical interpretation of geometric forms, was considered sacred, not academic. Pythagoras himself is recorded as having spent 22 years in Egypt, studying at the temples before he established his school at Croton. He was not inventing a new philosophy, he was recovering an ancient one. What connects these traditions is not merely the geometry they preserved, but the attitude toward it. The insistence that this knowledge was sacred, restricted, and transmitted only through initiated channels. This is not the behavior of people who have discovered a useful engineering technique. This is the behavior of people who understand themselves to be custodians of something vastly important, something that must be protected, preserved, and passed on in a form that will survive whatever threatens to destroy it. The medieval stonemasons' guilds that built Europe's Gothic cathedrals held the same conviction. They called their geometric methods operative secrets and guarded them from outside scrutiny with the same intensity that their philosophical heirs, the Freemasons, later applied to their ritualistic descendants of those same methods. The geometry of a Gothic cathedral and the geometry of an ancient Egyptian temple are not merely similar. In the proportional systems that govern them, they are the same. The tradition did not die with Egypt, it moved. Conventional archaeology has a standard answer for the similarities between ancient cultures. They developed independently, guided by the universal human tendency to respond to similar problems with similar solutions. Build a large structure and it will tend toward a pyramid shape because the pyramid is structurally stable. Observe the sky and you will eventually align your buildings with the sun. The same problems produce the same solutions. This explanation holds up reasonably well for general similarities. It begins to fail when the similarities become specific. A specific stone-cutting technique appears at Puma Punku in Bolivia and at ancient sites in Egypt. Not a general technique, a specific method of cutting precise right-angled channels into hard stone with flat-bottomed grooves that suggest a rotary cutting tool. Neither culture is credited with having rotary cutting technology. And yet the cut marks are identical, not similar. Identical, to a degree that tool mark analysts working independently on samples from both sites have noted. A specific construction method for megalithic walls, the use of polygonal, multi-sided blocks fitted together without mortar in an interlocking puzzle pattern, appears in ancient Peru, in ancient Egypt, in ancient Turkey, in ancient Malta, and in ancient Japan. In each case, the technique produces walls that absorb seismic energy rather than cracking under it. This is not an obvious engineering solution. It requires a specific and sophisticated understanding of how stone behaves under stress. It was supposedly invented independently by each of these cultures. Artifacts appear in archaeological contexts where they should not be. A carved stone sphere, showing a level of precision in its spherical form that would challenge modern machining, found in a stratum in Costa Rica, dated to a period when the local culture is not credited with the technology to produce it. Stone tools made from obsidian found at sites whose nearest obsidian source is hundreds of miles of open ocean away in a period before any known maritime tradition capable of crossing that water. Botanical evidence of contact-specific cultivated plants appearing on both sides of the Pacific in periods when the oceans between them are supposed to have been impassable. The ocean was not a barrier. Evidence from multiple disciplines, linguistics, botany, genetics, and the analysis of ancient boat-building traditions increasingly supports the conclusion that ancient peoples navigated the open ocean far earlier and far more extensively than the conventional timeline allows. The Polynesian achievement of navigating the entire Pacific without instruments using stars, currents, wave patterns, and the flight paths of birds demonstrates a level of maritime capability that makes ancient Atlantic crossings entirely plausible. The geometry that appears in structures on both sides of every ocean on Earth did not travel through the air. It traveled with people. The question is who those people were. In 1996, geologist Robert Schoch stood before the Sphinx of Giza and reached a conclusion that Egyptologists have been arguing against ever since. The Sphinx, Schoch determined from the erosion patterns on its body, was weathered not by wind-blown sand, the erosion pattern that would be expected if it had sat in a desert for 4,500 years, but by prolonged rainfall, deep, vertical fissures in the rock, characteristic of water erosion rather than wind erosion, running down the sides of the Sphinx enclosure. This type of erosion requires sustained precipitation over a long period. The last time the Giza Plateau received that level of rainfall, according to climatological records, was prior to approximately 7000 BC. Some estimates push the relevant wet period further back still, to 10,000 BC. If Schoch is correct, and his analysis has been supported by other geologists, though contested by Egyptologists, then the Sphinx is significantly older than the conventional date of 2500 BC assigned to it, possibly much older, which means that whoever originally carved it did so in a period before any civilization that conventional history acknowledges. The Giza Plateau itself, when viewed as a complete, planned complex, encodes astronomical information. The orientation of the plateau and the relative positioning of the three pyramids, analysed by astronomer Robert Bovell, corresponds to the positions of specific stars as they appeared in the sky around 10,500 BC, a date 8,000 years before the pyramid's conventional construction date. The plateau appears to have been laid out according to a plan designed to reference a very specific moment in the deep past. Something is pointing backward, pointing toward a time before Egypt, before Sumer, before any civilization that the textbooks acknowledge. And geology has now provided a mechanism for why that time is hidden from us. The Younger Dryas impact event, a cosmic collision or airburst, supported by physical evidence found on 4 continents, in the form of a distinctive layer of nanodiamonds and shocked quartz, deposited at precisely 10,800 BC, which triggered a catastrophic climate reversal, melted much of the northern hemisphere's ice sheets, and raised global sea levels by an estimated 100 to 120 meters. 120 meters. The world's most densely populated places have always been coastlines. If a technologically sophisticated civilization existed before 10,800 BC and built primarily on coastal land, that civilization is now 60 to 120 meters underwater. We have not failed to find it because it did not exist. We have failed to find it because we have been looking in the wrong places. Here is the thing about the ancient builders that changes the entire picture. They were not just building, they were watching. Watching the sky with a patience and precision that we have only recently, with the help of computers and satellites, begun to approach. And what they were watching was not the sky as it looked in their own time. They were watching the sky over thousands of years, tracking a motion so slow that no single human lifetime, or even 100 human lifetimes, could observe its full cycle. The Earth wobbles. As it spins on its axis, that axis itself traces a slow circle, completing one full revolution approximately every 25,772 years. This is called precession of the equinoxes. Because of precession, the stars appear to gradually shift their positions relative to the horizon over very long periods. The constellation that rises at the spring equinox changes over the millennia. The pole star changes. The entire celestial sphere slowly rotates through the sky on a timescale that dwarfs any individual civilization. To detect this motion requires continuous, precise, astronomical records spanning not decades, but centuries. The ancient builders had such records, or rather, their structures demonstrate that they did, because the astronomical alignments encoded in those structures are not alignments to the sky as it appeared at the time of construction. Many of them are alignments to the sky as it appeared thousands of years before construction, or thousands of years after. Stonehenge encodes multiple points in the precessional cycle simultaneously, its various phases incorporating alignments to different stellar configurations that span thousands of years. The Giza Plateau's layout corresponds to the sky of 10,500 BC. Angkor Wat's geometry encodes precessional dates. The Mayan long count calendar is fundamentally a precessional calendar, a count of time measured against the 25,772-year Great Cycle. These structures are not merely observatories for the present sky. They are records of the long sky monuments that track a celestial motion, too slow for any single generation to observe, preserving the knowledge of that motion in physical form so that it could not be lost. They are time capsules, not metaphorical time capsules, precisely calibrated ones. And the time they are calibrated to does not match the era of their construction. It matches something earlier. And in several cases, it matches something that, from the builder's perspective, had not yet arrived. The ancient builders were writing messages in a temporal language. They were building for a future they could calculate, but could not see. A future that, if you check the precessional mathematics, includes a period that corresponds closely to the era we are currently living in. Take a globe, a physical one, if you can find it, and place a mark on it for each of the following: Stonehenge, in southern England; the Great Pyramid of Giza, in Egypt; Angkor Wat, in Cambodia; Easter Island, in the southeastern Pacific; the Nazca Lines, in the Peruvian desert; Machu Picchu, in the Peruvian highlands; Teotihuacan, in central Mexico; Tiwanaku, on the Bolivian Altiplano; Göbekli Tepe, in southern Turkey; the ancient city of Mohenjo-Daro, in the Indus Valley; the megalithic temples of Malta; the massive earthworks of Cahokia, in the American Midwest. Now look at the marks. 12 sites. Every inhabited continent represented. Sites separated by oceans and mountain ranges, built by cultures that conventional history describes as isolated from one another, spanning thousands of years of construction dates. Connect them. Researcher Jim Allison, working with tools that allowed him to analyze geographic relationships with precision, found that these 12 sites, when connected on a globe, to lie on or extremely close to a single great circle, the geometric equivalent of a straight line drawn across a sphere, which is the shortest possible path between any 2 points on a spherical surface. A great circle is the largest circle that can be drawn on a sphere's surface, passing through 2 antipodal points. The 12 most significant ancient megalithic sites on Earth lie on the same great circle with a margin of error that statisticians have calculated as having a probability of occurring by random chance of approximately 1 in a billion. 1 in a billion. This is not an interpretation or a theory. It is a geometric fact. It can be verified with the coordinates of the sites and a basic knowledge of spherical geometry. The sites are where they are. The great circle passes through them. The mathematics is not in dispute. What is in dispute is the implication. Mainstream archaeology's response has been, largely, silence, not refutation. The geometric fact has not been challenged. Simply a reluctance to ask the question that the fact demands. If these sites were placed along a designed global pattern, who designed it? When was it designed? And what were the navigational and mathematical capabilities required to position structures at specific points on a global coordinate system from which no portion of the Earth's surface is visible in its entirety? These are not comfortable questions, but they are the only honest response to what the globe shows. In 1921, a businessman and amateur archaeologist named Alfred Watkins was riding across the hills of Herefordshire in England when something caught his attention. Looking at the landscape from a high point, he observed that ancient sites, standing stones, old churches, prehistoric earthworks, ancient trackways appeared to align with one another along straight lines that ran for miles across the countryside. Not approximately, precisely. Watkins spent years documenting these alignments, which he called ley lines from the Old English for a cleared strip of land. He published his findings in a book called The Old Straight Track, and the archaeological community took them seriously enough to debate them at length. He was not a mystic. He was a methodical observer who had found something real in the landscape. What happened next is instructive. Over the following decades, the cultural associations surrounding ley lines drifted progressively away from archaeology and toward occultism, UFO theories, and various forms of alternative spirituality. By the mid-20th century, the phrase ley line had become so contaminated by fringe associations that serious researchers were professionally reluctant to use it. The concept was not disproved. It was abandoned, which is a different thing, and a thing that happens more often in academic history than the academic world likes to acknowledge. The actual evidence, examined without those cultural distractions, is this. In Britain, statistically significant alignments of ancient sacred sites along straight geographic lines have been confirmed by surveyors working independently of any alternative history agenda. The Street, Michael Line, an alignment connecting Street Michael's Mount in Cornwall with Glastonbury Tor, Avebury, the Bury Street. Edmund's Cathedral site, and several other ancient sacred places, runs for nearly 350 miles, with a precision that surveyors have confirmed cannot be accidental. Similar alignments have been documented in France, in Egypt along the Nile corridor, and in Mexico along the Avenue of the Dead at Teotihuacan, which continues as a line connecting other sacred sites at precisely calculated distances. More provocative is the electromagnetic dimension. Geophysicist Paul Devereux spent years conducting careful measurements at standing stone sites in Britain and discovered something that his instruments confirmed repeatedly. Standing stones in Britain are disproportionately positioned at points where the local geomagnetic field is measurably stronger than the surrounding terrain at anomalies in the Earth's electromagnetic field. These anomalies are detectable with modern instruments. The stones were placed there 6,000 years ago. The question of how the ancient builders detected what modern instruments now measure is not one that conventional archaeology has provided an answer for. The same sensitivity to invisible environmental forces appears in traditions worldwide. Chinese feng shui, the Indian tradition of Vastu, Celtic geomancy, all describe systems of placing buildings in relation to invisible energies moving through the landscape. They use different names and different frameworks, but they are all describing the same phenomenon, an awareness, apparently possessed by ancient cultures on every continent, of something in the landscape that modern science has only recently developed instruments sophisticated enough to detect. Consider what it would mean to build a planetary machine. Not a machine in the obvious sense of gears and levers, but a machine in the broader sense, a system designed to interact with a natural force in a consistent and controlled way. A machine that uses the Earth itself as its medium. A machine whose components are spread across the entire surface of the planet, each positioned at a specific node in a global geometric lattice, each built to precise specifications that would cause it to function in a predictable way within the larger system. This is not a new idea. It is, in fact, the conclusion that several independent researchers working in different fields reached during the 20th century, and it is a conclusion that the geometry of the ancient world, examined honestly, does not easily refute. Buckminster Fuller, the architect and systems theorist whose work on geodesic structures revolutionized construction, identified a mathematical lattice that describes the Earth's surface as a geometric grid of interlocking triangles. The intersections of this grid, what Fuller called the world grid, corresponded, in his analysis, to locations of unusual geological and electromagnetic activity. When ancient sacred sites are plotted on Fuller's grid, they cluster at its intersection points with a precision that goes beyond coincidence. Ivan Sanderson, a biologist and researcher, identified 12 zones equidistant around the planet's surface where anomalous events, unexplained ship and aircraft disappearances, electromagnetic instrument failures, unusual gravitational readings occurred with statistically significant frequency. He called these the 12 Devil's Triangles. They are not random. They are geometrically evenly distributed across the globe. And they correspond to regions of unusual tectonic and oceanic activity, places where the Earth's own energetic structure is measurably different from the surrounding terrain. Bruce Cathy, a New Zealand pilot who became obsessed with UFO reports, spent decades mapping what he believed to be a specific mathematical grid overlaid on the Earth's surface, derived from the speed of light and harmonic mathematical relationships. His grid predicted specific positions on the Earth's surface, and when he checked those positions against the locations of ancient sites, nuclear test sites, and various anomalous phenomena, the correspondences were substantial enough that his mathematics were reviewed by independent analysts and found to be internally consistent. What these three researchers found, from three entirely different starting points, is the same thing. The Earth's surface has a geometric structure. Ancient builders appear to have known about it, and what they built at the nodes of that structure may not have been monuments to their gods. It may have been something considerably more functional nodes in a system whose purpose we have not yet fully understood, operating in a dimension that our current instruments are only beginning to access. The Great Pyramid is aligned to true north with an accuracy of 0.05 degrees. The Greenwich Observatory, the institution that defines north for the entire modern world, is aligned to true north with an accuracy of 0.09 degrees. The ancient structure is more precisely aligned to true north than the modern institution built specifically to measure north. This is not a contested claim. It is a measurement. Stonehenge was built at a latitude 51.18 degrees north. That is the only latitude in the British Isles where the summer solstice sunrise and the winter solstice sunset align perfectly with each other at a right angle. Change the latitude by a single degree and the relationship disappears. The builders chose this specific location on this specific latitude for a reason. They understood the geometry of the Earth's axial tilt well enough to select a location based on that understanding. The three pyramids of Giza, when viewed from the air, are not perfectly aligned with one another. The smallest is offset slightly to the east of the line formed by the other two. This has puzzled archaeologists for a century. It precisely mirrors the offset of the smallest star in Orion's belt, Mintaka, relative to the other two stars of the belt, Al-Nitak and Al-Nilam. The match is not approximate, it is geometrically exact, and the size ratios of the three pyramids mirror the magnitude ratios of the three stars. Angkor Wat was built at a latitude and orientation such that on the spring equinox, a person standing at the main entrance of the temple sees the sun rise precisely above the central tower. To achieve this alignment requires knowing the exact latitude of the intended construction site, the exact tilt of the Earth's rotational axis, and the exact position of the sun at the spring equinox. The Khmer builders possessed all three pieces of knowledge and used them with the precision of instrument-grade calculation. The Nazca lines of Peru, the enormous geoglyphs scraped into the desert surface by removing the dark upper layer of stone to reveal the lighter ground beneath, include several straight lines that run for miles without deviating from their course by more than a few meters. Some point to specific stellar rise and set positions, some point to sacred mountains, some point along the lines of underground water sources. None of them can be meaningfully appreciated from ground level. They are designed to be seen from altitude, from a vantage point that the culture that created them, by every conventional account, did not possess. The alignments are real. The calculations behind them are real. The civilization required to make those calculations is either invisible to us or has been systematically excluded from the story we tell about human history. Forget, for a moment, everything you learned about mathematics in school, not the calculations, the attitude. School mathematics presents numbers as neutral, abstract, and purely functional. The ancients had a different understanding. For them, certain numbers were not just quantities, they were keys, specific values that unlocked specific truths about the structure of the universe. And those keys keep showing up, carved into stone, built into proportions, encoded in dimensions, across every ancient culture on Earth. The number 432 is a good place to start. In the dimensions of the Great Pyramid, the relationship between its height and base perimeter encodes a factor of 43,200, a multiple of 432. In the Hindu Kali Yuga cosmological cycle, the duration of the current age of the world is 432,000 years. In the Babylonian historian Berossus's account of the kings who ruled before the Great Flood, the total span of their combined reigns is 432,000 years. In the Norse cosmological text, the Eddas, the Hall of the Gods at Valhalla has 540 doors, through each of which 800 warriors can pass 540 times. 800 equals 432,000. In the ancient Chinese calendar, a full cycle of the heavens takes 432,000 days. This number appears in traditions that supposedly had no contact with each other, encoding an astronomical value that relates to the precessional cycle. The number 108 appears with equal persistence. The average distance from the Earth to the Sun is approximately 108 times the Sun's diameter. The average distance from the Earth to the Moon is approximately 108 times the Moon's diameter. These are not approximate relationships, they hold to within a fraction of a percent. The number 108 is sacred in Hinduism, Buddhism, and Jainism, and appears in the design specifications of temples from India to Japan to Southeast Asia. It appears in the proportional relationships of stone circles in Britain. It encodes an astronomical constant that requires sophisticated measurement of both the solar and lunar distances to calculate. The number 72 is the number of years required for the celestial equinox to move 1 degree along the ecliptic due to precession. Detecting this motion requires continuous astronomical observation over a minimum of several centuries. The number 72 is encoded in the layout of Angkor Wat, in the dimensions of the Great Pyramid, in the proportions of Egyptian temples, and in numerous other ancient structures across the world. To encode 72 deliberately is to claim knowledge of the precessional cycle, knowledge that requires either an extraordinarily long observational tradition or access to records from such a tradition. These numbers are not coincidences. They are a vocabulary, and the ancient builders were writing in that vocabulary with a consistency that begins to look, at a certain point, less like independent discovery and more like fluency in a shared language. Stand, in your mind, at the base of the Great Pyramid of Giza. The structure in front of you is 138.8 meters tall. It was originally 146.5 meters, before the outer casing stones were removed to build medieval Cairo. Its base is a near-perfect square, 230.4 meters on each side. It covers an area of approximately 53,000 square meters. It is composed of approximately 2.3 million stone blocks, weighing on average 2.5 tons each, with some individual blocks weighing up to 80 tons. The total mass of the structure is approximately 5.9 million tons. These are the numbers everyone knows. Now here are the numbers that change things. Take the perimeter of the base 4 times 230.4 meters, which gives you 921.6 meters. Divide that by twice the original height of 146.5 meters, which gives you 293 meters. The result, 921.6 divided by 293 equals 3.14159 pi, to 5 significant figures. The pyramid encodes the most fundamental mathematical constant in existence to a precision that the ancient Egyptians' own written mathematical texts do not achieve. The Rind papyrus, the best surviving example of Egyptian mathematics, gives a value for pi equivalent to 3.16. The pyramid gives 3.14159. The building is more accurate than the books. Now look at the golden ratio. The slant height of the pyramid, the distance from the base midpoint to the apex, measured along the face, divided by half the base length, gives you 1.618 phi. The golden ratio, to 3 decimal places, and the apothem, the perpendicular distance from the center of a base edge to the apex, divided by half the base length, gives you 1.272, which is the square root of phi. The pyramid simultaneously encodes pi and phi in its proportions. These two constants are mathematically related. Their relationship is expressed through the Fibonacci sequence. A structure that encodes both simultaneously in different dimensional ratios is not a coincidence. It is a design. Now consider what happens when you scale the pyramid against the Earth. If you take the pyramid's original height, 146.5 meters, and multiply it by 43,200, you get 6,328,800 meters. The polar radius of the Earth, the distance from the center to the North Pole, is 6,356,752 meters. The difference is less than half of 1%. The pyramid's height is a scale model of the Earth's polar radius at a ratio of 1 to 43,200, and the pyramid's base perimeter multiplied by 43,200 gives you 39,813,120 meters. The circumference of the Earth at the equator is 40,075,000 meters. Again, the difference is less than 1%, well within the margin of measurement error of the original construction. The Great Pyramid is a scale model of the Earth at a ratio of 1 to 43,200. Encoded in its dimensions is a comprehensive knowledge of the Earth's size, shape, and geometry that was not independently achieved in Western science until the 18th century. And the scale factor, 43,200, is a multiple of 72, the precessional constant. The scaling of the model to the Earth is itself an astronomical number. Whatever this structure is, it is not a tomb. There is a natural question that arises at this point, and it deserves an honest answer. If the mathematical encoding in the Great Pyramid is real, and it is, it can be verified by anyone with a tape measure and a calculator. Why does virtually no one in mainstream education know about it? Why is the standard school curriculum account of ancient Egypt focused on the political history of pharaohs rather than on the extraordinary mathematical achievements that the physical evidence demands we acknowledge? The answer is not simple, and it is not entirely flattering to the academic world. In the 19th century, this material was discussed openly and rigorously. John Taylor published The Great Pyramid. Why was it built and who built it? In 1859. The same year, Darwin published On the Origin of Species, a coincidence that tells you something about the intellectual temperature of the era. Charles Piazzi Smith, the Scottish Astronomer Royal, spent months in Egypt in the 1860s, producing measurements of the Great Pyramid that are still cited by researchers today for their accuracy. Their work was published, debated, and taken seriously by serious people. What changed was not the evidence. It was the cultural context. The early 20th century brought a wave of scientific positivism and a growing discomfort with the idea that ancient civilizations had possessed sophisticated knowledge. This discomfort is difficult to fully separate from the colonial attitudes of the period, the ideological investment in the narrative of progressive Western civilization, representing the apex of human intelligence. To acknowledge that ancient Egyptians or pre-agricultural stone circle builders had encoded mathematical constants that European scholars were still working out felt, in that cultural moment, like the wrong direction. The research was not refuted. It was simply allowed to become professionally inconvenient. The more recent dynamic is different, but equally problematic. The genuine mathematical evidence has been adopted enthusiastically and indiscriminately by a culture of pseudoscience, alien contact theory, and numerological mysticism that has made serious academic engagement with the real data professionally costly. A physicist or mathematician who engages carefully with the actual measurements of the Great Pyramid risks being associated with a cultural world that includes flat earthers and ancient astronaut theorists. The most rational response to that association, from a career perspective, is to avoid the topic entirely. And so the silence continues, sustained not by the absence of evidence, but by the discomfort of what the evidence implies. The implications do not become less real because they are uncomfortable. Numbers do not care about the careers of the people who measure them. The Fibonacci sequence begins with 2 ones. 1 and 1 are added to make 2, 2 and 1 are added to make 3, 3 and 2 are added to make 5, 5 and 3 make 8, 8 and 5 make 13, 13 and 8 make 21. The sequence continues indefinitely, each term the sum of the 2 before it. 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, and onwards into numbers beyond convenient naming. What makes this sequence extraordinary is what happens as it progresses. Divide any term by the one before it, and you get a ratio. Divide 3 by 2, and you get 1.5. Divide 5 by 3, and you get 1.667. Divide 8 by 5, and you get 1.6. Divide 13 by 8, and you get 1.625. Divide 89 by 55, and you get 1.6182. The ratio converges, with each successive term, toward a fixed value, 1.61803. Phi, the golden ratio. The sequence and the ratio are not different mathematical objects. They are the same object expressed in 2 different ways. One as a static proportion, one as a dynamic process of growth. This is why the Fibonacci sequence appears everywhere that life grows. A shell grows outward by adding new material proportional to what already exists, producing a spiral governed by phi. A sunflower grows new seeds from its center outward, packing them in opposing spirals whose numbers are always consecutive Fibonacci numbers. A tree branches such that each branching increases the total number of branches by a Fibonacci count. Life itself, at the most fundamental level of its growth mathematics, follows the Fibonacci sequence because phi is the most efficient ratio for packaging growth, the proportion at which the next generation is optimally related to the current one. The ancient builders encoded this principle of living growth in their most permanent structures. The proportions of the Parthenon's internal spaces follow nested Fibonacci ratios through multiple levels. You can draw the sequence of golden rectangles inside the building, and each space contains the echo of the larger 1. The tower heights of Angkor Wat's main complex are related by Fibonacci proportions. The compound stone circles of Scotland, rings within rings, are sized according to Fibonacci relationships between inner and outer diameters. What the ancient builders were encoding was not merely mathematics. It was the principle of life, the mathematical law by which living things grow. They were embedding the logic of the living world into structures of stone that could not decay, could not be burned, could not be erased by any catastrophe short of the destruction of the earth itself. They were building the mathematics of the living into the permanent. And there is something in that act, something in the deliberateness of it, the care of it, that feels less like engineering and more like a message. Like a parent who, knowing they may not be around to teach their child, writes down everything important in a form that will last. Here is where the mathematics becomes genuinely unsettling. The ancient builders did not merely encode the present in their structures. Several of the most carefully studied ancient monuments encode specific future dates, dates that can be calculated with precision and that correspond to specific moments in the precessional cycle. The past and the future were not separate categories to the ancient builders. They were positions on a wheel, and they had mapped the wheel. Angkor Wat encodes the precession of the equinoxes in its architectural proportions. When the temple's internal measurements are converted into astronomical units using the measurement system of the Khmer builders, they describe the positions of specific stars at specific precessional moments. Researcher Graham Hancock, working with astronomer John Grigsby, demonstrated that the geometric relationships built into the temple's layout correspond to the night sky, as it will appear at a specific point in the current precessional era, a date that falls within living memory, or close to it, depending on the precision of the encoding. The Mayan long count calendar is not merely a count of days, it is a precessional calendar, a system for tracking the 25,772-year cycle of the equinoctial precession. The date that the long count counts toward is not an arbitrary endpoint. It is a precessional marker, a moment when the Earth's orientation relative to the galactic center reaches a specific configuration that the Maya identified as astronomically significant. Their temples, particularly the pyramid at Chichen Itza, encode this calendar not in inscriptions, but in the geometry of the structure itself. The number of steps, the proportions of the terraces, the angles of the stairways, all are calibrated to the precessional mathematics. The Great Pyramid's internal geometry has been analyzed by several researchers as encoding not just spatial information but temporal information, a sequence of architectural markers along its internal passages that several analysts have interpreted as a chronological timeline of human civilization. The correspondences between specific architectural features and specific historical periods, if the interpretive framework is accepted, include several events from the past 2 centuries that the builders could not have known about through any process recognizable as prediction. These interpretations may be wrong, they are not established fact, but the temporal encoding itself, the fact that ancient structures encode future precessional dates, is established. The ancient builders were writing in time as well as in space. They were placing coordinates not just on the globe, but on the great wheel of the cosmic year. And several of those coordinates point toward now. Before electric light, the sky was unavoidable. On a clear night, away from any settlement, the sky above an ancient human being was not the pale, star-sparse dome most city dwellers experience today. It was overwhelming. 3,000 visible stars, the slow river of the Milky Way spanning the entire horizon. The moon, not a background detail, but a presence, a clock, a calendar, a lamp bright enough to cast shadows. The slow movement of the planets against the fixed stars, tracing paths that repeated with the precision of machinery. The sunrise and sunset marking east and west with absolute consistency. The solstice positions marking the extremes of the sun's annual journey, with positions that, if you paid attention, never changed from year to year. The sky was the most reliable thing in the world. Everything else changed, seasons brought death and renewal, rivers flooded and receded, human affairs shifted in every conceivable direction. But the stars rose and set in the same places, on the same nights, year after year, millennium after millennium. They were the one fixed frame of reference in a world that offered very few certainties. They were the anchor. For ancient cultures, astronomical observation was not a scientific discipline in the modern sense, an intellectual pursuit separate from practical and spiritual life. It was all three simultaneously. Tracking the sun's position along the horizon gave you the agricultural calendar, when to plant, when to harvest, when the rains would come. Tracking the stars gave you navigation, the ability to find north, to maintain a bearing across a featureless sea or desert. And the patterns in the sky gave you the largest available framework for understanding where humanity stood in relation to everything else. The concept of stellar theology, the practice of encoding astronomical knowledge in religious architecture so that the sacred landscape mirrored the sacred sky, arises from this unified understanding. If the divine order is expressed in the movements of the heavens, and a temple is meant to be a dwelling for that divine order on earth, then the temple must accurately mirror what is above. Any deviation from precise alignment is a theological failure, a building that is asking the divine to inhabit a structure that does not honestly represent it. This is why the angles matter. This is why the orientations were measured with obsessive precision. It was not vanity or perfectionism. It was the fundamental requirement of what the building was supposed to do. To build a temple, misaligned with the sky, was to build a broken instrument. And the builders of the ancient world were not in the habit of building broken instruments. Most people know one thing about Stonehenge, that the sun rises over the heelstone at the summer solstice. This is true. It is also the least interesting astronomical fact about the monument. Let's begin with what the site actually is, because the popular image, a circle of standing stones, is a snapshot of one phase of a construction history that spans 1,500 years and involves at least 3 distinct building programs by different cultures. The earliest phase, dating to approximately 3000 BC, was a circular earthwork enclosure containing 56 evenly spaced holes arranged around its perimeter. These holes, the Aubrey holes, named for the antiquary who noted them in the 17th century, were long regarded as mysterious features with no obvious purpose. Their purpose, worked out by astronomer Gerald Hawkins in the 1960s, is an eclipse predictor. By moving a marker one position around the ring of 56 holes per year, the structure's users could track the 18.6-year lunar nodal cycle, the period after which the moon returns to the same position relative to the ecliptic, with sufficient precision to predict when solar and lunar eclipses would occur, years in advance. This is a sophisticated astronomical computation system built in chalk and post holes by a culture that conventional history credits with basic tribal organization and no written mathematics. The monument continued to develop over the following 15 centuries. New phases added stone circles, then the famous horseshoe of massive trilithons, the pairs of vertical stones topped by horizontal lintels that give Stonehenge its distinctive silhouette. Each phase was not independent of the previous ones. Each was geometrically integrated with what came before, suggesting that each generation of builders understood not just how to continue the project, but how to read the existing structure and extend its capabilities. The final phase incorporates alignments not just to the sun and moon, but to specific stars that were rising in significant positions during the Bronze Age. The structure's multiple astronomical alignments represent a deliberate record of the sky at different points over a span of at least 1,000 years of observation. When plotted against the full 25,772-year precessional cycle, the structure's various alignments correspond to different positions in that cycle, as if the builders were creating a permanent record of the sky's slow rotation, encoded in the positions of the stones themselves. Stonehenge is not a monument to the summer solstice. It is a complete astronomical library, and it was written, revised, and extended by 15 centuries of builders who all understood the same language. Section 6.3 Giza and the Age of Orion. In 1989, a construction engineer named Robert Bauval was lying on his back in the Egyptian desert, looking up at the stars. He had been thinking for years about the layout of the 3 Giza pyramids, specifically about the fact that the smallest of the 3, Menkare's pyramid, is offset slightly to the east of the line that would connect the other 2 if they were perfectly aligned. Egyptologists had never adequately explained this. The builders were clearly capable of perfect alignment when they wanted it. The base of the Great Pyramid is aligned to the cardinal directions with extraordinary precision. The offset was intentional. But what did it mean? Looking up at Orion's belt that night, Bauval had the recognition that changed his career and provoked an ongoing controversy in Egyptology. The 3 stars of Orion's belt are not perfectly aligned either. Mintaka, the westernmost of the three, sits slightly to the side of the line formed by the other two Al-Nitak and Al-Nilam. The offset mirrors the offset of Menkare's pyramid exactly, and the relative sizes of the three pyramids mirror the relative brightnesses of the three stars. And the Nile, running to the east of the Giza Plateau, corresponds to the Milky Way, which runs to the east of Orion. The three pyramids are a ground map of Orion's belt. The Giza Plateau is a terrestrial representation of a specific region of the sky. But here is where the story becomes genuinely radical. Due to the precession of the equinoxes, the stars slowly shift their positions relative to the horizon over the 25,772-year cycle. Orion's belt was not in the same position in the sky in 2500 BC, the conventional construction date of the pyramids, as it is today. And neither position is the one the Giza layout encodes. The position that the Giza layout perfectly mirrors the orientation at which the three pyramids and the three stars of Orion's belt are aligned along the same meridian. With the Milky Way and the Nile, in perfect correspondence, is the position Orion occupied around 10,500 BC. 8,000 years before the pyramids were built, the builders were not encoding the current sky. They were encoding a sky from the very deep past. Either they had records of the night sky from 10,500 BC, which requires the existence of a civilization capable of astronomical record-keeping that far back, or the Giza complex is actually far older than the date conventionally assigned to it. Either conclusion is extraordinary, and there is no third option that preserves the conventional timeline intact. On the morning of the spring equinox, something happens at Angkor Wat that the Cambodian jungle conceals most of the year. The sun rises. This is not the remarkable part. The sun rises due east on the equinox from every point on Earth. What is remarkable is the alignment of that sunrise with the specific architecture of the temple, an alignment that requires not just knowledge of the equinox, but precise knowledge of the latitude of the site, the exact orientation of the building relative to true east, and the height of the central tower relative to the causeway entrance from which the observation is made. All three variables were engineered simultaneously to create a moment in which, when you stand at the temple's main entrance, the sun appears to rise from directly above the central tower's peak, balanced there for an instant before continuing its ascent. This is not a natural coincidence. It is a designed optical event, calculated and built with the precision of a theatrical production running on a 90-year rehearsal schedule. But the equinox alignment is Angkor Wat's most visible feature, not its deepest one. Eleanor Manika, an art historian who spent 30 years studying Angkor Wat's proportions, published her findings in 1,996 inches, a work that demonstrated something far more intricate than solar alignment. The measurements of the temple complex, when converted to the unit of distance used by the Khmer builders, a unit called the hat, express specific astronomical values with precision. The axial distance from the main entrance to the temple's central tower encodes in hat units the length of one yuga cycle from Hindu cosmology, a cosmological time period that is itself a fraction of a precessional cycle. The number of steps in various stairways encode the months of the solar and lunar years. The circumference of galleries encodes the number of days in specific celestial cycles. The full temple is a three-dimensional astronomical encyclopedia, its physical dimensions functioning simultaneously as architecture and as calendar. The precessional encoding at Angkor Wat, when analyzed, identifies a specific era in the precessional cycle, not the era of the temple's construction in the 12th century AD, but an era approximately 6,000 years earlier, the same deep time reference that the Giza Plateau encodes. Two structures, built 1,000 years apart, on opposite sides of the known world, pointing at the same moment in the long history of the sky. The probability of that coincidence occurring randomly is not worth calculating. It is simply not random. There is one thing that is the same from every point on the surface of the Earth. Not the landscape, not the climate, not the plants or animals, or the shape of the horizon. The sky. From Cairo or Cusco or Angkor or Stonehenge, the same stars rise and set. The same sun marks the same solstice positions. The same moon follows the same cycle. The same great wheel of the precessional cycle turns at the same rate. The sky is the one universal constant of human experience, visible from every culture on every continent, measurable with the same tools available to every civilization. This is why the ancient builders chose the sky as their medium. If you wanted to encode a message that could be read by any sufficiently advanced culture, regardless of where on Earth that culture arose or what language it spoke, you would encode it in astronomical relationships. Because those relationships are universal, they require no translation, no cultural context, no shared language. They require only the mathematics that any civilization capable of measuring the heavens would inevitably develop. A civilization sophisticated enough to detect the precession of the equinoxes, which requires centuries of continuous astronomical records and the mathematical framework to interpret them, would recognize a precessional encoding in an ancient structure. A civilization with the mathematics to calculate pi and phi would recognize those constants encoded in architectural proportions. A civilization with the geodetic knowledge to measure the Earth's circumference would recognize that circumference encoded in a pyramid's dimensions. These are not encrypted messages requiring a specific code key. They are messages in the universal language of mathematics, legible to any culture that has achieved the specific intellectual milestones required to understand them. The ancient builders chose the recipients of their message carefully. They were not writing for their contemporaries, who lacked the instruments and mathematical frameworks needed to decode the full depth of what was encoded. They were writing for a future civilization, for the civilization that would eventually develop the tools, the mathematics, and the astronomical knowledge needed to read what had been written in stone. We are that civilization. We have the instruments. We have the mathematics. We can measure the precessional cycle and recognize it in the temples of Cambodia. We can calculate pi and phi and find them in the proportions of Egyptian pyramids. We can map the Earth and discover that its dimensions are encoded in a monument 5,000 years old. The message has arrived. The question now is what it says. The word megalithic comes from the Greek megas, meaning great, and lithos, meaning stone. It describes a form of construction, the building of large structures using massive stone blocks, often without mortar, often with a precision that challenges the conventional understanding of the culture's technical capabilities. And the first thing you notice when you begin to map megalithic construction across the planet is that it is everywhere. In Britain and Ireland, thousands of standing stones, stone circles, and megalithic tomb structures date to between 4,000 and 1,500 BC. In continental Europe, France, Spain, Portugal, Scandinavia, Germany, tens of thousands of dolmens, menhirs, and passage tombs cover the landscape, several predating the Egyptian pyramids. The megalithic temples of Malta, on a small Mediterranean island, were built beginning around 3,600 BC, making them among the oldest freestanding stone structures on Earth, older than Stonehenge and older than the Great Pyramid. Cross to North Africa and the Middle East. The Egyptian pyramids are the most famous, but the ancient sites along the Nile from Aswan to Sudan include megalithic structures spanning thousands of years of construction. Göbekli Tepe and related sites in Turkey push megalithic construction back to 9,500 BC. The ancient city of Baalbek in Lebanon contains monolithic blocks of a scale that has no parallel in the modern world. Travel east. The temples of India are built on megalithic principles extending from prehistoric times. The rock-cut structures of Ellora and Mahabalipuram suggest a stone-working sophistication that conventional dating struggles to account for. In Southeast Asia, Angkor Wat and the hundreds of other Khmer temple structures represent megalithic construction on an industrial scale. Across Indonesia and the Pacific, megalithic traditions persist on islands as remote as Easter Island and as obscure as Nias. Go to the Americas. The Inca walls of Cusco and Sacsayhuaman represent megalithic stone fitting of a precision that no modern reconstruction attempt has successfully replicated. The pyramids of Teotihuacan, Chichen Itza, and Cholula place Mexico among the world's major centers of pyramidal megalithic construction. Bolivia's Pumapunku contains stone blocks cut to tolerances that suggest methods outside the known technological capability of the culture assigned to them. Every inhabited continent, every era, from the deep Neolithic to the historical period, all sharing the same fundamental characteristics: precision beyond what the assigned cultures should have possessed, geometric encoding of mathematical constants, astronomical alignments, and a consistent vocabulary of architectural forms that appears in places where no cultural contact can be demonstrated. The pattern is planetary, and planetary patterns require planetary explanations. Let us be precise about what it means to say that two ancient structures share the same proportions. It does not mean they look similar. It does not mean they are both large or both made of stone. It means that when you measure specific dimensional ratios, the relationship of height to base perimeter, the slope angle of the faces, the encoding of mathematical constants in the relationship between measurable lengths, the numbers match. Not approximately, precisely, within the margin of measurement error of the original construction. The Great Pyramid of Giza and the Pyramid of the Sun at Teotihuacan in Mexico both encode pi in the relationship between their base perimeter and height. The Pyramid of the Sun has a base perimeter of 895 meters and an original height of approximately 71 meters. The ratio of its perimeter to twice its height is approximately 2 times pi. The same encoding, the same mathematical constant, the same precision. Two pyramids, two continents, two civilizations, separated by 10,000 kilometers and 1,000 years of construction time, both encoding the same mathematical constant in the same architectural relationship. The Borobudur Temple in Java, Indonesia, built in the 9th century AD, encodes the golden ratio in the proportional relationships of its successive terrace levels. The ratio of the diameter of each terrace to the one below it follows a phi-based sequence. The Parthenon in Athens, built in the 5th century BC, the same century as Borobudur, encodes the golden ratio in the relationship between its facade width and height. These two structures, built on opposite sides of the world within the same historical century, by cultures with no documented architectural exchange, express the same mathematical constant in their most visible proportional feature. The stone circles of South Korea, the ancient dolmen fields of Gochang, Hwasun, and Ganghwa, which are collectively among the densest concentrations of megalithic structures anywhere on Earth, follow proportional systems in their spatial arrangements that correspond to the proportional systems of stone circles in Ireland and Britain. These traditions are separated by the entire breadth of Eurasia and by the Yellow Sea. They developed, according to conventional archaeological chronology, independently and simultaneously. There is a thought experiment that clarifies the situation. Imagine you are a teacher, and you give the same mathematics problem to two students who are sitting in separate rooms with no ability to communicate with each other. One comes from Korea, one from Ireland. They both submit the same answer, expressed in the same way, to the same number of decimal places. What do you conclude? You do not conclude that they independently arrived at an identical solution by entirely different mental paths. You conclude that they both had access to the same source, the same textbook, the same prior instruction, the same foundational learning. That is what the proportional evidence in the ancient world requires us to conclude. What if each ancient monument is not a standalone structure? What if each is a chapter in a book, a complete, coherent, globally distributed text about the nature of reality? The more carefully the geometry of the ancient world is analyzed, the more this possibility demands consideration. The structures are not merely geometrically sophisticated in isolation. They are geometrically sophisticated in relation to one another, in relation to the sky, in relation to the earth itself, and in relation to the fundamental mathematical constants that govern physical reality at every scale. They form a system, a complete description of the universe, encoded in stone, distributed across the surface of a planet. Consider the 3 layers of the encoding. The first layer is mathematical, the constants encoded in ancient structures. Pi, phi, the Fibonacci sequence, the square roots of 2, 3, and 5 are not arbitrary sacred numbers. They are the fundamental ratios that appear in the mathematics of physical reality, from quantum mechanics to cosmological structure. Pi describes the relationship between a circle and its diameter at every scale, from an atomic orbit to a galactic arm. Phi describes the growth mathematics of living systems, from a viral protein coat to the branching of neurons. These are not human inventions, they are features of the universe. The second layer is astronomical. The solar year, the lunar month, the eclipse cycle, the 25,772-year precessional period, all encoded simultaneously in the same physical structures. A complete model of the solar system's temporal behavior, expressed in architectural dimensions, functional as a calendar at multiple timescales simultaneously. The third layer is geographic. The Great Pyramid encodes the Earth's polar radius and equatorial circumference at a scale of 1/43/200. The placement of major ancient sites along great circles encodes knowledge of the Earth's spherical geometry. The precise cardinal alignments of multiple structures across multiple continents encode knowledge of the Earth's axial orientation. Together, the geographic relationships of the ancient world's sacred sites constitute a model of the Earth's shape, size, and position in space. Mathematical constants, astronomical cycles, planetary dimensions. These three categories of information, encoded simultaneously in the same global network of physical structures, constitute a complete cosmological model. Not a model of what the ancient builders believed the universe to be. A model of what the universe actually is, expressed in a mathematical language that modern physics is still in the process of fully decoding. Someone built an encyclopedia of the cosmos. They built it in stone, and they distributed it across the entire surface of the planet. There are exactly three explanations for what the evidence shows. The first is independent discovery. Every ancient culture that encoded pi, phi, and precessional mathematics in its architecture did so through its own independent observation of nature, guided by the same universal logic that makes these mathematical constants discoverable by any sufficiently careful observer of the natural world. This is the mainstream archaeological position. It has real intellectual merit. The golden ratio is genuinely observable in nature, without any prior mathematical framework, and the basic movements of the sun and moon are genuinely available to any culture that watches the sky with persistence. The explanation becomes strained when applied to the specific numerical coincidences, the same exact values to multiple decimal places, the same precessional constant of 72, the same scale relationship of the Great Pyramid to the Earth, but it is a coherent position. The second explanation is cultural transmission. The geometric knowledge spread through contact between ancient cultures via maritime routes, via migrations, via the movement of an initiated class of builders whose knowledge constituted a kind of international technical language. This explanation handles most of the cross-continental similarities plausibly. The Phoenicians, we know, travelled extensively. The Polynesians navigated the Pacific with extraordinary precision. New genetic and botanical evidence continues to accumulate for pre-Columbian contact between the Americas and the Old World. The explanation struggles most with the oldest sites, the ones built in a period before any maritime tradition capable of crossing oceans is conventionally acknowledged. The third explanation is common inheritance. All ancient geometric knowledge ultimately derives from a single pre-civilizational tradition, a culture that existed before the civilizations we know, that possessed advanced mathematical and astronomical knowledge, and whose existence was largely erased by a catastrophe approximately 12,800 years ago, leaving behind only the stone structures built on high ground and the geometric tradition transmitted by survivors into the successive cultures that followed. The Younger Dryas impact event, whose physical evidence has been confirmed in the peer-reviewed geological literature, provides the mechanism. The anomalous depths of geometric knowledge at the oldest sites Göbekli Tepe, the Sphinx complex, provide the temporal evidence. None of these explanations is entirely satisfying. Each accounts for some of the evidence and struggles with the rest. The most intellectually honest position is to hold all three simultaneously and follow the evidence wherever it leads, with the full understanding that the destination may not be a comfortable place. Ancient builders capable of producing the geometric precision demonstrated in the structures we have examined were clearly not making mistakes accidentally. And yet, across the ancient world, in structures on every continent, a specific and consistent deviation from perfect regularity appears. It is not structural error. It is not a limitation of tools or materials. It is a deliberate insertion of asymmetry into structures that are otherwise geometrically perfect, a controlled imperfection placed at a specific point in the overall design. In ancient Egyptian temples, the phenomenon is documented and named astronomical skewing. The rear wall of a temple, the wall furthest from the public entrance, the wall that faces the innermost sanctuary, is built very slightly off perpendicular to the axis of the structure, by fractions of a degree, invisible to casual observation, detectable only by precise measurement. The Egyptians themselves made no attempt to correct it. Later phases of construction at the same temples maintained the same skew. It was not error, it was specification. In Inca stonework, the otherwise perfectly fitted polygonal walls include occasional stones of different character blocks that interrupt the pattern, that introduce an irregular note into an otherwise harmonious construction. Archaeologists have called these correction stones, without fully explaining why correction was needed in walls of otherwise unmatched precision. At Stonehenge, the trilithon horseshoe is not perfectly symmetrical. One of the gaps between the massive stone pairs is measurably wider than the others. This gap is positioned at the monument's astronomical axis, the sight line toward the midsummer sunrise. The imperfection is placed precisely where perfect geometric attention would be focused. Ancient philosophy from multiple traditions explains this behavior. Pythagorean, Hindu, Egyptian, and Islamic architectural traditions all contain explicit doctrines of deliberate imperfection, the intentional introduction of a flaw into any human construction, as an acknowledgement that only the divine can achieve true perfection. To build without such a flaw is an act of hubris, a claim to a perfection that belongs to the cosmic order, not to human hands. The same philosophy, the same gesture, the same position in the structure, worldwide. This is not a parallel development. This is a shared inheritance from a tradition that understood both the geometry of the cosmos and the appropriate human relationship to it. A text written in an unknown language does not announce its nature. It looks, to the uninitiated eye, like meaningless marks on a surface. The transition from meaninglessness to meaning does not happen in the marks themselves, it happens in the reader. Fluency is not a property of the text. It is a relationship between the text and the person encountering it. Ancient sacred geometry is a text. It has been in plain sight for as long as the structures that encode it have stood. Every person who has ever visited the Great Pyramid, Stonehenge, Angkor Wat, or any of the hundreds of other geometrically encoded ancient sites, has stood in the presence of the message. Very few have read it. Not because the message is hidden, it is literally carved in stone, in the most public and permanent form available, but because fluency in the language requires a specific kind of attention that modern culture does not routinely cultivate. The practice of reading architectural geometry as intentional communication, what some scholars call geometric hermeneutics, has a long history. The Neoplatonic philosophers of the ancient Mediterranean world analyzed the proportions of temples as philosophical texts, extracting cosmological meaning from the ratios of columns, the relationships of interior spaces, the angles of pediments. Iamblichus wrote detailed accounts of how the proportions of Egyptian temples encoded the relationships between the divine archetypes. Proclus analyzed Euclid's geometry not as mathematics, but as philosophy, each theorem a statement about the structure of reality. In the Renaissance, architects like Palladio and Alberti consciously attempted to recover the ancient proportional systems they believed were encoded in Roman and Greek buildings, producing works whose harmonic proportions were intended not as aesthetic choices, but as statements about cosmic order. The Gothic cathedral builders of medieval Europe used specific geometric methods, the secret of the compass and the square that their guilds guarded, so carefully to produce buildings whose interior proportions were precise. Instruments for creating specific states of contemplation in the people who inhabited them. Reading the message in the ancient stones requires the same approach these traditions used. The understanding that the proportions are intentional, that they encode meaning at multiple simultaneous levels, and that no single decoding exhausts the content. The geometry is not a one-dimensional code that yields a single plaintext message. It is a multi-layered system in which the same relationships express mathematical, astronomical, philosophical, and cosmological meanings simultaneously. The most honest approach is not to extract one meaning and declare the cipher solved. It is to allow the multiple layers to remain in simultaneous awareness, the way a skilled reader holds the simultaneous meanings of a poem without flattening it into prose. Let us attempt a reading. Take 5 first. 1.618, the golden ratio. In the ancient philosophical traditions that encoded it, phi was understood as the mathematical expression of the most fundamental relationship in reality, the relationship between a whole and its parts. Phi is the only ratio at which a line can be divided, so that the proportion of the whole to the larger part equals the proportion of the larger part to the smaller part. It is a self-referencing relationship. The whole contains the part in the same way the part contains the smaller part. It is the mathematical description of a system that is coherent at every scale, where the structure of the whole is mirrored in every subdivision. The ancient traditions called this the divine proportion, because it described the way they understood the divine to operate, as a unity that is present in every fragment of itself, undivided by subdivision, whole at every scale. A structure built according to phi ratios is not merely aesthetically pleasing, it is, in the terms of the ancient framework, a three-dimensional statement about the nature of unity, a physical expression of the philosophical claim that the cosmos is a coherent whole in which every part reflects the structure of the whole. Now, take pi. The ratio of a circle's circumference to its diameter is an irrational number. It extends to infinite decimal places without ever repeating. The ancient world universally understood the circle as the symbol of the divine, perfect, endless, self-contained, without beginning or end. Pi is the number that connects the finite to the infinite. It is the ratio that allows you to calculate the precise boundary of a form that is, in philosophical terms, boundless. A structure that encodes pi in its proportions is making a statement about the relationship between the finite and the infinite, between the measurable, bounded world of human experience and the immeasurable, unbounded divine order that contains it. A structure that simultaneously encodes both phi and pi, which is precisely what the Great Pyramid does, is saying something very specific. The divine circle, pi, infinity, and the living spiral, phi, growth, share the same geometric foundation. The same mathematics that governs the infinite also governs the finite. The same ratios that appear in the proportions of a human body also appear in the proportions of the cosmos. The universe is not divided into the sacred and the mundane. It is one coherent system, mathematical through and through, at every scale from the smallest living form to the largest observable structure. This is not a mystical claim. It is a mathematical observation, an observation that modern physics is actively confirming, finding the same harmonic relationships at the quantum scale that the ancient world encoded in temples. The ancient builders were not being poetic, they were being precise. They were building a statement about the structure of reality that had to be stated in the language of reality itself in mathematics, because no other language would be sufficient, and no other medium would be permanent enough to last. Here is what a message written for the future would look like if you wanted to construct one that could survive any catastrophe and be decoded by any sufficiently advanced civilization. You would not write it in a language, because languages decay and die and leave no inheritors who can read them. You would not write it on organic material, because organic material burns and rots and dissolves. You would not write it in a form that requires the survival of any particular cultural context, because cultures collapse without warning. You would write it in mathematics. Mathematics does not decay. Mathematics does not require cultural context. Any civilization advanced enough to measure the earth, to observe the sky with precision, to calculate the cycles of the heavens, any such civilization, regardless of its origin, language, religion, or history, will independently arrive at the same mathematical values. Pi is pi everywhere. The precessional cycle is 25,772 years everywhere. The Earth's circumference is 40,075 kilometers everywhere. If you embed those values in a physical structure built of the most durable material available, stone, and you build that structure at a scale large enough that it cannot be accidentally destroyed and at a location unlikely to be submerged by geological change, you have created a message that will survive indefinitely and be readable by any civilization that has achieved the mathematical and astronomical milestones required to decode it. This is precisely what the ancient builders did. The Great Pyramid encodes the Earth's circumference, but only a civilization that has measured the Earth can decode that encoding. It encodes pi to 4 decimal places, but only a civilization that has developed the concept of pi as a mathematical constant can recognize it. It encodes the precessional constant of 43,200, but only a civilization that has tracked the sky for long enough to detect the precession of the equinoxes will know what that number means. The message contains its own admission criteria. If you can read it, you have already demonstrated that you are the intended audience. And there is a third piece of verification data: the encoding of the precessional cycle simultaneously in multiple structures on multiple continents, all pointing towards specific dates in the great cycle of the heavens. Those dates are not the era of the structure's construction. They are addressed to a future civilization, to the civilization that, at those precessional moments, will have the sky that the stones are aligned to. The ancient builders knew, with the precision of mathematics, when their message would be readable. They encoded the date of its delivery into the message itself. They built for recipients they could calculate but never meet. There are mornings in the desert when the air is so still that you can hear the light. Not literally, but the ancient builders understood something about silence, about the specific quality of silence that surrounds an object that is charged with knowledge. A library after closing. A letter not yet opened. A stone placed at exactly the right angle to catch a light that will not come for another 6 months. Every morning for 5,000 years, the sun has risen. And at Giza, at Stonehenge, at Angkor Wat, at Machu Picchu, at 100 sites whose names are still known, and 1,000 whose names are forgotten, the light has fallen exactly where someone calculated it would fall. The shadow moves exactly as planned. The alignment holds. The geometry performs its function on every equinox, every solstice, every morning of every season, year after year, century after century, while the civilizations that built it rise and fall below it, while languages are born and die, while empires are forgotten and new ones grow from their graves. What does it mean to be the generation standing before a stone that was placed with deliberate mathematical precision by someone who knew they would not live to see it decoded? There is a particular weight to that position, a weight that is not quite reverence and not quite obligation, but something between the two. The feeling of being in the presence of an intelligence that was capable of thinking across timescales that make individual human lives invisible. An intelligence that looked at the precession of the equinoxes, a cycle so slow that no single lifetime can detect it, and said, "This matters. Someone in the future will need to know this." And then built the knowing into stone. The stones have been waiting. Not passively, the light has been doing its work. The shadows have been moving. The geometry has been performing every day without an audience that understood what it was watching. But waiting for a specific kind of audience. An audience that has, by the time it arrives, developed precisely the tools and knowledge required to understand the performance. An audience that will arrive at the site and realize, with a sensation that is close to vertigo, that they were expected. The most humbling thing about the ancient monuments is not their size or their precision or even the mystery of their construction. It is the evidence that someone, a very long time ago, thought carefully about us, about who we would be, what we would know, what we would need, and built it in stone so we could find it. But there is a darker reading. The ancient world was unanimous about one thing that modern culture has largely set aside. Time is not linear. It is cyclical. The cosmos does not progress in a straight line from primitive to sophisticated, from chaos to order. It moves in cycles, great cycles, measured in the precessional period, in which civilizations rise and fall not once but repeatedly, and in which specific phases of the cycle bring specific kinds of catastrophe. The Hindu Kali Yuga, the Mayan long count, the Norse cosmological cycle that ends in Ragnarok, the Platonic Great Year, the Egyptian concept of Zep Tepi, the primordial time before the current era. Every ancient cosmological tradition on Earth contains the same fundamental structure, a cycle of time, measured against the precessional period, in which the world passes through phases of increasing darkness and eventual destruction, followed by renewal. These are not myths in the dismissive sense of that word. They are cosmological frameworks that correspond, in their mathematical structure, to the actual precessional cycle. The geological record confirms that catastrophic events, comet impacts, massive volcanic eruptions, sudden climate shifts, rapid sea level changes do occur on timescales that correspond to specific phases of the precessional cycle. The Younger Dryas impact event of 12,800 years ago falls precisely at a precessional transition. The evidence of civilizational collapse that appears in the archaeological record at approximately 2200 BC, a global collapse that ended the Old Kingdom of Egypt, the Akkadian Empire, the Indus Valley Civilization, and several other Bronze Age cultures, simultaneously falls at another precessional transition. If the ancient builders knew that catastrophe clusters at specific precessional positions, and the evidence suggests they tracked those positions with precision, then the message encoded in the stones is not primarily a celebration of cosmic order. It is a survival document, a record of what has happened and what will happen again, encoded in a form that will outlast the catastrophe and be readable by whoever rebuilds afterward. The builders may not have been enlightened cosmologists contemplating eternity from a position of security. They may have been survivors, encoding the knowledge of their destroyed world in the only form they knew would last, leaving it for whoever came after. The message in the stones may be, above all else, a record of catastrophe and a warning of its return. In the spring of 1865, a man climbed to the top of the Great Pyramid. He was not a tourist. He was Charles Piazzi Smyth, the Astronomer Royal of Scotland, one of the most technically accomplished scientists of the Victorian era, equipped with precision measuring instruments of his own design. He had come to Egypt with a specific purpose: to verify, with the rigor appropriate to a professional scientist, the mathematical claims that amateur researcher John Taylor had published 6 years earlier about the pyramid's proportions. Taylor, a London publisher with a serious interest in mathematics, had argued that the pyramid encoded pi in its dimensional relationships. Smith intended to determine whether this was true. He spent months at Giza. He measured the pyramid from every angle, with every instrument he had brought. He remeasured his measurements. He accounted for the missing outer casing stones that would have altered the pyramid's original dimensions. He published his results in 4 dense volumes of meticulous technical data. His conclusion: Taylor was right. The pyramid encoded pi, and several additional mathematical relationships besides. Smith's work was taken seriously. It was debated by serious people. A parliamentary committee heard testimony about it. William Flinders Petrie, who would become one of the founding figures of modern archaeology, went to Egypt specifically to re-examine Smyth's measurements. And while he questioned some of Smyth's more extravagant interpretive claims, his own precise surveys confirmed the fundamental mathematical accuracy of the pyramid's dimensions. The pi encoding was real. The proportional precision was real. And then, gradually, it stopped being discussed. The early 20th century brought a decisive shift in academic culture toward what historians of science call scientific positivism, a philosophical stance that was deeply skeptical of any narrative crediting ancient or non-Western cultures with sophisticated technical knowledge. The teleological narrative of progress, the story in which humanity advances steadily from primitive darkness towards scientific enlightenment, with Western civilization at the leading edge, made it professionally uncomfortable to acknowledge that ancient Egyptians, or pre-agricultural stone circle builders, had encoded mathematical constants that European scholars were still working out. The discomfort had ideological roots that are difficult to fully separate from the colonial attitudes of the period. By the mid-20th century, the mathematical analysis of ancient structures had become associated partly through genuine fringe adoption, partly through academic abandonment that created a vacuum quickly filled by less rigorous thinkers with numerology, alien contact theories, and various forms of pseudoscience that made serious engagement professionally costly. The evidence did not change. The institutional response to it did. The most important recent development in the study of ancient sites is not a new theory. It is a new instrument. In 2015, a team of physicists and engineers began an international project to scan the Great Pyramid of Giza using muon tomography, a technique developed to scan volcanic mountains and nuclear reactors for internal structure by detecting the cosmic ray particles called muons that continuously shower the Earth from space. Muons penetrate stone, but are absorbed at different rates, depending on the density of the material they pass through. By placing detectors inside known chambers and measuring the directional flux of muons from above, the scanner can build a three-dimensional picture of the structure's interior, including any cavities or voids not previously known. In November 2017, the results were published in the journal Nature. A large void had been discovered inside the Great Pyramid, a space at least 30 meters long, positioned above the Grand Gallery, with no known access point and no documented purpose. It was the first major internal discovery in the pyramid in over a century. Its geometric position within the pyramid, analyzed against the known mathematical encodings in the structure's proportions, is not random. It corresponds to a specific location in the geometric system. What it contains, and what its builders intended it for, remains unknown. The field of acoustic archaeology has produced equally striking results at other ancient sites. Researchers at Newgrange in Ireland found that the stone chamber's dimensions produce a resonance frequency of approximately 110 Hz, a frequency that studies in psychoacoustics have identified as particularly effective at suppressing the rational processing centers of the brain and inducing altered states of consciousness. The same resonance frequency was found at the Hal Saflieni Hypogeum in Malta, a series of underground chambers carved from solid rock approximately 5,000 years ago, and at the oracle chambers of Chavín de Huántar in Peru, where the stone galleries produce specific acoustic effects that researchers believe were used in ceremonial contexts to alter the consciousness of participants. These structures were not merely geometrically sophisticated, they were acoustically engineered. They were physical instruments, designed to produce specific effects in the human mind and nervous system effects, consistent with the ceremonial and initiatory practices that the ancient traditions surrounding these sites describe. The builders were not just architects, they were in the most precise sense of the term engineers of human experience. Every era in the history of science has its outside researchers, the figures who follow the evidence to conclusions that the mainstream is not ready to accept, who absorb the professional costs of intellectual honesty, and who are sometimes vindicated decades or centuries after their central insights are confirmed. John Michel stands first in this tradition for the study of ancient sacred geometry. His 1969 work, The View over Atlantis, was the first systematic attempt to map the geometric and numerical systems underlying the sacred landscape of ancient Britain, the alignment of sites, the astronomical orientations, the specific numerical values encoded in the proportions and positioning of prehistoric monuments. His later work on what he called the ancient canon of number traced a consistent set of numerical values, many of them related to the precessional cycle and the dimensions of the Earth across multiple ancient cultures, arguing that this consistency implied a common source tradition. Michel was too early for the computational tools that would later allow his observations to be verified at greater precision, but the central observations have held up. Robert Bauval's Orion correlation theory, published in a mainstream Egyptological journal in 1989, and subsequently expanded into a series of books co-authored with Adrian Gilbert and Graham Hancock, proposed the ground-sky correspondence of the Giza pyramids with Orion's belt and demonstrated, through astronomical calculation, that the correspondence encoded the sky as it appeared around 10,500 BC. The theory has been attacked by Egyptologists, primarily on chronological grounds, and defended by astronomers who have verified the geometric calculation. The debate has not been resolved. The mathematics has not been refuted. Graham Hancock's broader research program, spanning more than 3 decades, has consistently argued for the existence of a pre-Younger Dryas civilization whose knowledge is preserved in the geometric and astronomical encodings of the world's ancient sacred sites. His collaboration with geologist Randall Carlson on the physical evidence for the Younger Dryas impact event, now confirmed in the peer-reviewed geological literature, provides the geological mechanism that his historical hypothesis requires. His work has moved progressively from the intellectual margins toward a position where its central claims are being confirmed by mainstream researchers, who may not cite his work, but are finding the same evidence. These figures have not been vindicated because they were right about everything. They were not. They have been incrementally vindicated because they were right about the things that mattered most: the precision of ancient astronomical knowledge, the global distribution of a common geometric tradition, and the reality of a catastrophe that disrupted an advanced prehistorical culture. The evidence they pointed toward was always real. What changed was the willingness of the mainstream to look at it. Let us be clear about what the evidence in this documentary actually supports and what it does not. The evidence supports the following. Ancient builders worldwide possessed precise knowledge of fundamental mathematical constants pi and phi in a period centuries or millennia before those values appear in any surviving written mathematical tradition. This is demonstrated by the measurable dimensional relationships of physical structures that can be visited and verified. It is not interpretation, it is measurement. The evidence supports the following. The builders of the most significant ancient sites possessed knowledge of the Earth's circumference and polar radius that was not independently achieved in Western science until the 17th and 18th centuries. This knowledge is encoded in the dimensions of the Great Pyramid at a scale factor of 143/200, verified by geodetic researchers whose calculations have been independently confirmed. The evidence supports the following. Multiple ancient cultures tracked the 25,772-year cycle of the precessional equinoxes with sufficient precision to encode it in architectural dimensions and astronomical alignments. This requires either centuries of continuous astronomical observation or access to records from such observation. The precessional constant of 72 years per degree of equinoctial precession appears in structures and cosmological cycles across cultures with no documented astronomical contact. The evidence supports the following. The major ancient sites of the world are positioned with a geometric precision relative to each other that exceeds what random placement can account for, suggesting intentional geographic positioning according to a global coordinate system. What the evidence does not conclusively establish is the identity of the knowledge source. It may have been a lost pre-Younger Dryas civilization. It may have been a global network of initiated builder priests, preserving and transmitting a common tradition. It may have been the independent discovery of the same universal mathematical truths by multiple sophisticated cultures. Each explanation accounts for some of the evidence. None accounts for all of it. What the evidence cannot be accommodated by is the conventional narrative that ancient people lacked sophisticated mathematical and astronomical knowledge. That narrative is contradicted by measurement. The measurements are not going away. There is one more fact. The Great Pyramid of Giza is located at 29 degrees, 58 minutes, and 45.28 seconds north latitude. Convert that to decimal degrees, 29.9799245, 8 degrees north. The speed of light in a vacuum, in meters per second, is 299,792,458. The latitude of the Great Pyramid multiplied by 10 million equals the speed of light. Take a moment with that. 29.9792458 times 10 million equals 299,792,458. The pyramid's latitude coordinate, scaled by a factor of 10 million, gives the speed of light to 9 significant figures. The speed of light was not measured to this precision until 1862, when the French physicist Léon Foucault used a rotating mirror apparatus to calculate it as 298 million meters per second close, but not yet at the precision encoded in the pyramid's latitude. The definitive modern value was established in 1983, when it was fixed by international scientific agreement at exactly 299,792,458 meters per second. The Great Pyramid was built approximately 4,500 years ago and sits at the latitude that encodes the most fundamental constant of physics to 9 significant figures. This correspondence has been noted and independently verified by multiple researchers. It is not a numerical trick or an approximation. The coordinates are what they are. The speed of light is what it is. The relationship between them is exact. What it means is a question that has no comfortable answer within the conventional history of science. To place a structure at a specific latitude requires the ability to measure latitude, which requires sophisticated astronomical observation. To place it at a latitude that corresponds precisely to the speed of light requires either the ability to measure the speed of light, which requires physics that was not developed until the 19th century, or a knowledge of what the speed of light is that came from somewhere other than the history of science as we currently understand it. The pyramid sits where it sits. The light travels at the speed it travels, and the number that describes one of those facts is encoded in the number that describes the other. This is the stone that shouldn't exist. We have travelled far to arrive at this question. Through the stone-cut precision of Baalbek and the mathematical proportions of Giza, through the astronomical alignments of Stonehenge and the cosmological encodings of Angkor Wat, through the global patterns of sacred sites and the recurring numbers that appear in stone on every continent, we have followed a thread. And the thread leads here to the question that everything else has been building toward. Who was the silent architect, whose geometric signature appears in ancient stone on every inhabited continent, in every era, with a consistency that demands a single explanation? There are 4 possible answers. They are not mutually exclusive. They may all be true simultaneously, each describing a different aspect of the same reality from a different vantage point. The first possible architect is a lost civilization, an actual human culture, older than any civilization currently in the historical record, that possessed advanced mathematical and astronomical knowledge and encoded it in stone structures around the world before a catastrophe erased the civilization itself. The evidence for this possibility is substantial. The geological confirmation of the Younger Dryas impact event, the anomalous age and precision of the oldest ancient sites, the water erosion patterns on the Sphinx, the precessional encodings that reference dates far earlier than any recognized civilization. The explanation is coherent. It requires only that we accept the existence of a civilization we have not yet found, in an era for which the evidence is mostly underwater. The second possible architect is not a single civilization, but a distributed tradition, a global network of initiated builder priests, who preserved and transmitted geometric knowledge across cultures and centuries, maintaining the thread of an ancient wisdom through the collapse of individual civilizations, encoding it in new structures as old ones fell. Every culture touched by this tradition believed itself to be preserving received knowledge rather than creating original knowledge. The evidence for this possibility is the consistent testimony of the traditions themselves. The third possible architect is the cosmos. The mathematical constants encoded in the ancient world, pi, phi, the Fibonacci sequence, are properties of the universe, not of any culture. They are discoverable by any sufficiently observant intelligence anywhere. What if the ancient builders were not transmitting a human knowledge tradition, but independently discovering the same universal truths, guided to the same conclusions by the same cosmic logic that structured the reality they were observing? The fourth possibility asks the most difficult question. What if the ancients were not merely observing the universe, but receiving information from it? Several ancient traditions describe their foundational geometric knowledge as literally given to them by the gods, by divine intermediaries, by a source external to human society. This is not a claim that demands belief. It is a claim that demands attention, because it is made with remarkable consistency by cultures that had no contact with one another. Perhaps all 4 answers are the same answer, seen from different angles. The standard account of human intellectual history tells a particular kind of story. The story begins in the Neolithic, when early humans developed agriculture and settled into villages. It moves through the Bronze Age, when writing was invented and the first cities appeared. It climbs through ancient Greece, where mathematics and philosophy were developed with increasing sophistication. It reaches the European Renaissance, when classical knowledge was recovered and the foundations of modern science were laid. It culminates in the Enlightenment and the Scientific Revolution, when empirical methods produced the explosion of knowledge that defines the modern world. And it places us, the present, at the apex, the most technologically sophisticated humans who have ever existed, standing at the endpoint of an unbroken ascent from primitive origins. This is a compelling story. It is also, in the light of the evidence we have examined, deeply and perhaps fundamentally incomplete. If the Great Pyramid encodes pi more precisely than the ancient Egyptian mathematical texts, then the mathematical knowledge available at its construction exceeds the mathematical knowledge documented in the same culture's written record. If the pyramid also encodes the Earth's dimensions, the precessional constant, and the speed of light, then the knowledge available at its construction exceeds what Western science independently achieved until the 18th and 19th centuries. The apex of the standard story is not the apex of the actual story. The evidence suggests a different narrative structure, not a line ascending from primitive to sophisticated, but a spiral, a recurring cycle in which mathematical and cosmological knowledge reaches sophisticated levels, is periodically disrupted by catastrophe or institutional collapse, and must be recovered, re-encoded, and transmitted again. Every era that we credit with a great mathematical or scientific discovery may have been, more precisely, an era of recovery. Pythagoras, studying in Egypt for 22 years before founding his school. Leonardo da Vinci, tracing the golden ratio in the proportions of the human body, finding what the ancients had already built. Renaissance architects recovering the harmonic proportions of Gothic cathedrals from the geometric traditions of the stonemasons. Modern physicists finding the same harmonic ratios in quantum-scale energy levels that ancient builders encoded in temple proportions. We are not the first civilization to know these things. We may not be the most complete in our knowledge of them. We are one more cycle in a spiral that began before our history starts rediscovering, with modern instruments, what was encoded in stone thousands of years ago for us to find. The geometry is not historical. This is the thing that the ancient builders seem to have most wanted us to understand. The proportions they encoded in stone are not properties of ancient architecture. They are properties of reality constants that are as present and operative now as they were when the first hand pressed the first chisel to the first block of limestone. The golden ratio is not in the pyramid. It is in the universe. The pyramid is where someone chose to make it visible. Look at the world around you with this understanding and see what changes. The building you are in right now, if it was designed with the harmonic proportions that serious architects have always considered optimal for human comfort, the proportions that make a room feel right without being able to say why, encodes the same geometric relationships the ancient builders encoded. The spiral of a hurricane seen from a satellite follows the same mathematics as the spiral of a Nautilus shell, and the spiral of the Milky Way, and the spiral of the Fibonacci sequence built into the proportions of a 1,200-year-old temple in Cambodia. The geometry is alive. It is not a style choice, or a cultural preference, or a mathematical curiosity. It is the operating system of the physical universe. The set of mathematical relationships by which energy organizes itself into matter, by which matter organizes itself into living forms, by which living forms organize themselves into minds capable of recognizing the pattern and asking what it means. The ancient builders encoded this geometry in stone, not to create a museum of mathematical curiosities, but to create a permanent access point, a set of physical objects, precisely calibrated, that would produce the specific perceptual experience of recognizing the pattern in anyone attentive enough to engage with them. The stones are still functioning. Every equinox, every solstice, every morning, the light falls where it was placed. The proportions hold. The geometry is still present, still operative, still inviting the specific quality of attention that recognizes it. The invitation is not to study the ancient world. It is to develop the same perceptual relationship to geometric reality that the ancient builders possessed to see, in the proportions of a shell, and the dimensions of a room, and the branching of a tree, and the spiral of a galaxy, the same pattern, the same mathematics, the same ancient and permanent signature of an intelligence that was shaping the universe long before any civilization existed to observe it. Here is what the evidence, followed all the way to its end, actually says. Ancient builders, distributed across every continent, across thousands of years, consistently encoded specific mathematical and astronomical information in permanent stone structures positioned at specific points on the Earth's surface. The information encoded pi, phi, the precessional cycle. The Earth's dimensions represents knowledge that modern science validates as fundamental and accurate. The astronomical alignments of these structures encode specific dates in the Great Precessional Cycle, including dates that correspond to the era we currently inhabit. The global distribution of these structures follows geometric patterns that require knowledge of the Earth's spherical geometry. This body of evidence requires the existence of a sophisticated mathematical and astronomical tradition far older than any currently recognized in the historical record. Whether that tradition originated in a lost pre-Younger Dryas civilization, in a global network of initiated keepers, or in the independent genius of multiple ancient cultures guided by the same universal truths, it produced a global archive encoded in the most durable possible medium, addressed to a civilization with the knowledge to read it. We are that civilization. We have the mathematics to recognize pi in an ancient ratio. We have the astronomy to identify a precessional encoding. We have the geodesy to confirm the Earth's dimensions in a pyramid scale. We have arrived at precisely the moment in the precessional cycle that the structures appear to have been pointing toward. We are the intended recipients. But the message, as we have seen, is not merely informational. The geometry it encodes phi, pi, the Fibonacci sequence, is not only a description of the external universe, it is a description of us. Modern neuroscience has identified Fibonacci patterns in neural firing sequences, phi ratios in the branching structure of neural networks, harmonic mathematical relationships in the frequency patterns of consciousness itself. The ancient builders encoded the structure of the cosmos, and the structure of the cosmos is also the structure of the mind that perceives it. The geometry is not in the stone, it is not in the sky, it is in the mind that looks at the stone and recognizes the sky in it. The ancient message was never about monuments. It was about what the monuments point toward. It was about the moment of recognition, the moment when a human being looks at a proportion encoded in ancient stone and understands that it is the same proportion encoded in their own hand, their own face, their own heartbeat, the same proportion that curves through the galaxies above them. That moment of recognition is the message. You are not separate from the geometry. You are made of it. You always were. At dawn, the light comes in sideways. It has always come in sideways here, at this angle, at this season, because someone measured the angle and chose the stone and placed it precisely so that the light would do this, not today, but in every today that has followed from that original placing. The light does not know it is performing. The stone does not know it was designed. And yet the geometry holds, as it has held every morning for 5,000 years, patient and exact and silent. The shell on the shoreline curves in the same ratio as the stone above it. The tree at the edge of the plateau branches at the same angles as the proportions of the building beyond it. The spiral of the galaxy in the clear desert sky overhead follows the same mathematics as the spiral carved into the stone beneath your feet. There is no separation between these things. There never was. The ancient builders saw this and built it permanent. They held it up in stone so that it could not be forgotten, so that even after every text was burned and every language was lost, the proportions would remain, speaking in the one language that needs no translation, the language of the universe describing itself to itself. The genius of the ancient world was not that it knew things we do not know. It was that it knew how to remember, how to encode the most important things in a form that would survive every catastrophe, every forgetting, every ending. The stones were the memory, the geometry was the content. And the silence, the monumental 5,000-year silence of stone standing in landscape, was not emptiness. It was the space between two conversations, the pause before the response. The message was sent long ago. You have been receiving it your entire life, in the proportions of the faces you love, in the spirals of the natural world, in the mathematical resonances that the human mind finds beautiful without being able to explain why. The ancient builders did not create that resonance. They recognized it, and they cut it into stone so that you, standing here now, in whatever era this is, and wherever on earth you are, could recognize it too. The geometry was always the message, the stone was always the medium, and the silence, all along, was the loudest part.